Hi guys, welcome to Design Technology TV. Today we're going to be looking at an outstanding project. So this project will be from start to finish. That means that the video itself will cover all aspects that are required throughout the NEA project for OCR. Fundamentally though, I will not go into huge amounts of detail on every single aspect because there's going to be other videos within the series that cover that. This project, it is an outstanding project, there's no doubt about that. It is incredibly high level. Some aspects of it go above and beyond what is expected to get the grade. So in some sections, the grade might be out of 25, and it's happily, if you could mark beyond that, it would be marked beyond that. Also, this particular project is not officially endorsed by OCR. So the project itself has not been seen by OCR. It has not gone through any standardization or any other aspects. So in terms of it being outstanding, it is outstanding because I'm saying it's outstanding. That doesn't mean necessarily that the OCR themselves would agree with all statements that are within this video. As I say, it's not endorsed by OCR, so bear that in mind. But hopefully I can give you a fairly good steer. It's over 100 slides. There's no requirement that you do so many slides. However, for high-grade students, quite often what happens, they end up somewhere between 80 and 120 slides. It just happens. So don't panic about that. It's such a long project in terms of the number of hours that are put into it and the length of time over the course of months that are put into it, that quite often students will end up, particularly high-grade students, with that number of slides. It allows students to have enough range, enough depth to do so, but it is not required by the example. So don't think that just because this one's really long, you have to do the same. But more often than not, when we see students get really high grades, often they produce projects of this sort of size. A plagiarism warning. You should not plagiarize. So putting this up does not mean I'm putting this here for you to copy it. There are all sorts of quite severe sanctions for people who copy work or parts of work throughout either A-level, GCSE or degree. At degree, the likelihood is that you just get kicked straight off your course and you won't get any of your money back because you have cheated. That's the same for A-level. The likelihood is that you would just receive a U grade for your coursework, which could heavily impact on what you're doing, even if you plagiarize parts of what are in this project. So don't do it. Something that's important for you to realise is that I'm the lead trainer for OCR for DT, which means I'll be using this as a resource to train other staff across the country, which means they'll have seen it. So if you are not from St Brendan's and you produce a project that looks like this, it's quite a fairly high likelihood that your staff member will have already seen it and then they'll know that you've copied it. Equally, I'm going to be using this to lead the moderation team in training next year, which means that all the moderators will have seen this project. Therefore, if you use this project and it is chosen for moderation and you've copied sections of it, they'll be looking out for it, they'll see it, they'll spot it, they'll instantly say, right, this student has plagiarized resources that are available online, and instantly fail you. So do not steal bits of this, do not copy it. It is here to guide you and give you a resource as to sort of things of quality, ways to approach aspects, and to give you examples of what outstanding looks like. It is not here for you to copy. So even if you're doing a similar project, be wary that you do not want to find yourself copying or doing things that look very similar, because the likelihood is that you'll then be subjugated to some kind of plagiarism review, and if you are and found to be plagiarizing work, you will get a U grade. It's the only option because of malpractice rules within this, so bear this in mind. This is a great project to look through, do not copy it. So this project is about a prosthetic leg or a limb. The student starts with a guide to what sort of colours things mean. So she's already planning on how she's going to present her work, where she's going to make sure that the information is. One of the things that you can help yourself with is making sure that your slides are easy to navigate and there are obvious ways of working your way through it. What it means is that the person marking it can find the evidence that you're producing, and equally if it goes to moderation, then what happens is the moderators can go through it and they can easily identify aspects as well, which means they can agree with your staff member and their marking of the project. First of all, the student starts off with some feasibility analysis, looking at some generalized problems for aid in different areas. She also then looks at another project looking at broken bones during natural disasters, which is kind of where this project then leads from. She's doing some feasibility analysis, looking at strengths and weaknesses. You'll also notice there's pictorial images and quotes, which help to back up the feasibility. We're then getting into amputations, which is then what feeds into the whole major project. However, she's still looking at other aspects as well. So the level of depth and detail in the feasibility analysis is really good. So you can see how she's pulled apart several different projects before opting for her main choice. She's also looking at quite a range of different projects, so they're not necessarily that similar. Now, marketability. So marketability is important throughout the project to show that you're actually doing this for a marketable need. So make sure that when you start off your project, you know why you're doing it. You should have a problem or problems that you are solving. You should also understand that there is a marketable requirement for your product. If no one's going to buy it, your project is in a worrying place to start with. We've then got a slide on primary stakeholder, where she contacts them, speaks to them, and then gets some information from them. The blue box in the middle that's been covered up, that is the details, the contact details of this particular individual. So I've done that throughout the whole project. So if you see that, you can assume that. Within these projects, you'll also notice that I've pixelated images out of people's faces. In your own projects, there's no requirement for you to do that. That's if the people are happy for the photograph to be taken, then that's fine for you to have in your project, because only you, your teacher, and the moderator are going to see it. And if it then is used later on for moderation materials or exemplar materials, then OCR will pixelate the images out for you. So in yours, don't cover up faces, don't cover up email addresses, because it shows that you actually engaged in that. We have a design brief, so we've got desirable criteria and we've got key criteria, and showing what the main problems are. It's a really solid design brief in terms of showing what needs to be undertaken. We then move into who the stakeholders are, what they want from the project. Then in a bit more detail, then breaking it up. So we're having a conversation. The students are talking to each other and playing the roles of different users or stakeholders within the thing. And you can see the photograph on the top that proves that actually took place. Often, if there's a photograph within it that shows somebody working currently on your project, or also just group opportunities, or even discussing with your user, if you've got photographs of people doing that, it proves that those things actually happened rather than just you pretending they happened. It's a nice way of just making sure that the person marking your work understands that. More stakeholder needs, looking at some regulatory bodies and rules and various other bits of law. Now looking into sockets and some of the issues associated with it, so understanding how and what they need to attach to. Some bits of information they found elsewhere, looking at existing products. So this student actually went to an enablement centre and then discussed it with some professionals. She also found stuff on the internet as well. So she's got a range of different sources of information. She's looking at each of the different component parts within the project that's needed. Series of videos that she's found elsewhere, but they all help to understand what's going on with the project. An existing product review where she looks at different and related products. Then some more videos where she's looking at an actual live pylon. Anthropometric data, where she's looking at the important data and working out which bits are important to her and her project, including the paperwork that's used by the Enablement Centre as well. She then looks at the project in context. So she's looking at the range of motion and movement. And although she was able to find some things on the internet, she undertook first-hand testing. So this is photographs of her looking at how the heels strike, how the walk works, to make sure that she understands what range of motion and movement she needs to put into the project. And then she tries it on steps, slopes. This is really solid first-hand engagement with the project and the problems that are involved. Now we're looking at some very quick, simple models, just looking at range of motion. This kind of quality is absolutely appropriate at the start of any project where you're starting to look at initial ideas and movement, because what it's allowing you to do is to very quickly move through stuff. Back into some materials investigations where she's looking at possible materials that she might use. All the materials that she chooses are relevant. Some of them possibly get a little bit expensive, and you'll notice that she's starting to look in carbon fibre. It's an appropriate resource because it's lightweight. However, on the flip side, it probably isn't because of the project and the way she's ending up going with it. She looks at other appropriate materials that can be used for this. and then we get into her initial ideas, her sketch ideas. As you'll have seen in the initial ideas video, there is no requirement for the quality of your sketching to be this high from the start. However, this student, she did some quicker designs, wasn't happy with the quality of them, so she went back and redid them. We quite often see that. So it would be normal to see some rougher models, and you can argue that in fact, you would argue that the models that we saw a few slides ago, the basic cardboard ones, they are models, they are initial ideas, because they're showing range of motion, they're showing you experimenting and part of the process. Here we're starting to look at sketch analysis. As we go through this, not only is the quality really high, but you'll notice it looks and at the small details, the small component parts, and also it links in some of the research. She then takes it along to her primary stakeholders. They discuss it in the images, although you can't see it very well here. You can see these sketch sheets on the table in front of them as they discuss them. She then carries on with that feedback and starts moving forwards into other sketch designs, a range of different approaches. So there's a lot of different ways of coming at this. So she's not just picked one single approach, she's trying all sorts of different approaches with different components, different mechanisms, different styling. That really hits the higher marks in terms of initial ideas. And again, you can see she's starting to unpick them, look at the pros, the cons, and consistent evaluation. Bottom right hand corner, we're now starting to see that what she's completed and what her next steps are. So she's driving the process as she goes through, and you'll notice that you're able to track the changes of what she does as she goes through the project. So this is her proposed concept. So she hasn't made anything yet. She's going, right, this is kind of what I'm thinking about doing. Lovely bit of sketching, really high quality. And even if you are producing stuff that's a lot rougher than these sketches, having moments where you show your skills will then allow you to access higher marks later on. So within the quality marks, if you had much rougher sketching up to this point and then you had this sheet, you would still be able to access the highest marks for quality, because as long as your communication is appropriate and then you sort of showcase occasionally how good you are, absolutely fine. She then gets some feedback from her client, and you can see some next steps. Then she starts modeling. These models are cardboard. They are quite nice, and you'll notice in the bottom right hand corner she's starting to sketch over stuff, so she's integrating sketching. She's playing with the ideas she's doing, and you can see that they link into her initial idea sketches. She realizes she needs to do a bit of research on cogs and gears, so importantly the project is chronologically sound, so you can see that she's doing it as she needs to. The product then improves and there's some changes, and again we can see the photograph of the user, the stakeholders looking at this as well. She continues to look at good and bad points, continues to iterate. Another cardboard model, and it's a bit rough in places. Some of the cardboard's a bit bent and folded. It's not a problem at all. A video to show how it works is really helpful for us to understand what it is that she's doing. In any video you do, you should talk over it. Any silent videos are a bit pointless, to be honest. So always make sure that you're giving us context, what you're doing, why you're doing it, and how it works, what's good, what's bad. And even if that then actually is reiterated in some of the written work, that's absolutely appropriate. Now she's starting to play with some ideas. So she's done some different size lengths. And I think it's really important here to point out, look at the quality of the shaping and cutting. It's not good at all, and that is not a problem. Too often, A-level students waste absolutely ages making things absolutely beautiful to then produce way fewer models. What we want is lots of models of you trying and testing stuff. If you don't do enough models, you can't access the higher marks. It's plain and simple. So from your point of view, quicker, rougher models that allow you to move and make quick progress are absolutely appropriate. Yes, by all means, make some nice models occasionally, but they don't all have to be beautiful. So consider what's important to your project. So here she's gone through the rougher stage, and now she's starting to go back to foam. This is a better quality model, but in principle it's the same sort of thing, and again she discusses it with her users, their stakeholders. Because she's done that, she's then been introduced to this next component, which is unlocking NEA, and that's through having access to the stakeholders. So you can see how stakeholders really benefit her here. So they've discussed it with her, she knows and understands how it works, and she's able to do some analysis of it. That then starts linking into maybe a locking mechanism as she's working her way through, and she's now adapting the model that she made earlier and making changes to it. That continues to happen, and you can see the quality of the sketching here is nowhere near as good as it was previously. doesn't matter. This is absolutely appropriate. What's the point of spending hours on a beautiful bit of sketching when you've already proved how good you are, when all you're doing is you're showing an idea or a concept? Into some CAD. So the first bits of CAD are fairly simplistic and basic. She does then 3D print a piece just to see how that might look and how it might fit. We then move into some more focused material investigation. So she's coming back to the stuff she's already done and then making sure that it's appropriate to what she's going to do next. And she's looking at various different materials for different component parts within her project. Original sketch in the top left hand corner, and then she starts modifying and adapting it, and you can see how that changes into this cardboard model. So this foot design is really nice in terms of showing how it's going to work as she works her way through. She then starts modeling in some foam, and you can see she's trialing different ways. So she's using the same components for each of these three models, top, middle, bottom. However, she's then adapting or adding pieces to show different options. This kind of iteration is really quick to do, and it's really good in terms of you meeting the marks. You're trialing things, you're doing things, you're seeing what works, what's better, what is not as good. It's so quick to do, and this is what the project is all about, is you playing with ideas and seeing what you can do with them, rather than making lots of different models that are all independent and take ages to do. You'd be better off doing bits like this. Here again, we've then got a series of ideas that move through. You can see they're all based on each other, they all follow each other step by step. Cardboard is totally appropriate for this bit of modelling, and it's really nice to see the trialing to see how they move and bend and whether they do what they need to do. Again, this carries on and the parts get more complicated. Then we go back to sketching to better understand the small component parts that would probably be needed within the product to make the foot flex. Then we're looking at some linking and locking mechanisms, which were outlined on the previous page, and now they're starting to be played with to see what adjustments are possible. Again, we're going through here. Again, a rough model. It's got screws hanging out of it, but it's so appropriate in terms of showing the possibilities that are available to the student. She also then starts bringing in things like some of the children's foot size, because obviously that's completely appropriate to what she's doing at this stage. So understanding the size of it, going back to the research, doing a little bit of research as she needs, moving her way through. Back to some really basic weight transfer models to look at how that's going to work with the split foot design, and also then looking at some more fixing components. Another bit where she's going, right, this is an important point for me to say, this is where I'm at, this is what I think it's going to look like as I move forwards. Sketching here is awesome, quality is great, we can see all the component parts. This is absolutely fantastic in terms of design work. It's not a finished thing yet, but it looks really good. From that, she then goes, cool, I now need to make a model and I need to see how this actually looks physically. So she works her way through. Again, she's got feedback. And then that causes her to have adjustments. And these series of bits where she starts then playing with the foot design. She's using screws to show where they're going to go. She's understanding how this thing will not only be designed, but also how it's going to be manufactured and used by the user. This is really high-end stuff. Again, playing with different options. Trialing different ways of making it work. You can see she's looking at DFM, so she's looking for design for manufacture. Bring it up, show it, think about it, show that you understand that your product is starting to meet those requirements, or if it doesn't, why it doesn't. She was also a maths and science student, so she was quite happy with this sort of stuff. You don't need to bring in this kind of mathematics as a product designer. As a design engineer, we should probably see this fairly routinely, but she's making sure that the material and then the pylon itself is the right thickness to support the load of her user. Some more adjustments, so back to the research, and you'll see it pops up every time she needs it, it comes into the project. It's not all at the start of the project, it's absolutely throughout. This sort of stuff, 2D drawings, there's no point in doing this in 3D because of the complexity. 2D allows us to see all the component parts as an exploded view and understand how they fit together. Back to her initial ideas and showing us some of the things she's considered. And then she starts working on the socket as well. More feedback from the stakeholder, telling us what they think about it. And then she starts modeling. Again, back to these quicker, more simplistic models. I mean, I say simplistic, these are pretty full-on models in terms of the number of component parts, but she hasn't desperately worried about the complexity or the quality of all the cutting or all the component parts, but the shaping is the important aspect. Back to a bit more research, some 2D sketching to understand it in a bit more detail, a bit more feedback, and then she then starts sewing one herself. So importantly, as you go through this, show that you are actually undertaking it, and also in terms of your marks for the project, you need to make sure that you are showing that you've used hand tools, machine tools, CAD and CAM throughout this. So if you've got an opportunity to show that you're using a machine tool, then do so. Don't hide it from us. Different aspects here where we're looking at different opportunities to attach it. She wasn't amazing at sewing, but she did a really nice job, and it's clear that she's done it herself. We then look at some other component parts and fixings and studs. Now looking at 3D printing for component parts, because this is the way that she ended up manufacturing lots of her parts, but also how she expected it to be manufactured in real life. We're then starting to get into more complicated CAD because she's done all those lovely models earlier. We're now getting into the position where she understands what the CAD looks like. CAD is a really good tool for showing models and component parts and showing internal aspects, particularly for DFMA. However, lots of students get into CAD too early before they actually know what the design is going to look like. And because of that, what they end up doing is spending ages making models, which, although they look nice, are not really fit for purpose, don't really do very much, and they'd have been better off doing them in cardboard. So yes, use CAD, but only use it once you've got a sort of fairly solid design of what it is that you're going to do, because otherwise you just make something, realize it doesn't work, and then go, oh, and then have to make a whole new model, whereas it's much quicker to do that out of foam, cardboard, and cheaper modeling and quicker modeling materials. So as we work our way through, you can see her referencing back to previous models. She's adapting stuff, changing bits, considering how she can make something stronger or weaker, modeling all the component parts that are within the product. So the complexity here is excellent, but that's because she's done it all in foam, so she knew what she needed to do before she actually manufactured it in CAD. We then got her a sort of a marketing photo. I think this is probably one of the weakest parts of this in terms of just the visuals. It's nice, but it's not great, and the quality of the rendering isn't particularly fabulous. It's quite bitty, so a bit more time here. But then she spent so much time everywhere else, I don't think it's going to bring her mark down, that's for sure. Then we get into the specification for our technical specification, and we start looking through the different parts. So we see the whole product in as a single unit, and then we start breaking it down, and then it breaks down into each of the component parts. Now as you go through, you can see the majority of the dimensions on here. If your part is larger and you can't see the dimensions, to be honest, that's not going to be a major issue, providing we can see you going through the process. If we needed as a marker or as a moderator to get proof of the component part sizes, we could contact your center to get it later on. For the most part, if a moderator can't see all the dimensions, it's not a major issue. So right down to the small nuts, bolts, fixings, washers, and component parts. She's got everything here so we can understand what it looks like. So a third party could very easily manufacture this. It's got everything going on right the way through the whole product. We're now looking at manufacturing and industry, so how the product might actually be manufactured in real life. So we're thinking about how this is going to be used in real life. So this is part of the marketability of the product. It's also part of the feasibility of the final product. Considering how it's going to be made in real life, so it's all part of the technical specification here, but it shows a real understanding of what the important aspects are. We've also got some wider issues here as well. Talking about the component parts in terms of the stitching and some other manufacturing materials, and then into the cutting list for the product as a prototype model. All the different component parts are laid out here. Quite often we don't see it in this level of detail, but this student has gone all out to make sure she's got all components. We've then got her risk assessment. Her risk assessment is good because it links into other aspects. You can see she's got a fairly generic kind of aspect, but then she looks into more detail as we move way through. She's also looking at all the different machines that she is likely to use as part of her plan and what she intends to do. We then get into the printing and the diary of making. So she's talking through here the way that she's gone about it. She had a number of problems with the 3D printers because the 3D printers that she was using were quite cheap and they failed quite a lot. So she got quite used to fixing it. So she's showing her understanding of the different bits here. This understanding down the right hand side, the errors that she encountered and how to fix them, shows that she really did it. Really importantly, throughout the project, you want to be in a position where you show that it was you, not just some awesome technician that made everything for you. Show that you understand it yourself, that you really got involved and that you actually sorted this out and did it and you understood it. Carries on building through step by steps. She's taking photographs as she goes to show the problems she had as she went along. So she pre-planned it and then worked her way through, showing the issues that she had in manufacturing. She also then shows different ways of going back and changes and modifications that she might make. The images themselves allow us to see the internal components. So we can see the components which later on, when the whole product is put together, are missing and you can't see. So take photographs as you go to prove the quality of your modeling, particularly if you know the component parts are going to be hidden internally. If you've got an engineering project where you've got gearing and cogs and all sorts of other bits which are then going to be hidden by a housing, make sure there's plenty of photographs as you go through this stage to show us what you did so we can actually identify the internal components. This carries on, going through the different manufacturing plan and then step by steps what she did. There's proof of her using the machines herself. Again, this shows that not only did she do it, but also that she used machine tools, hand tools, CAD and CAM. Well, this carries on. And then she gets to her final model. So the final model is sprayed up, well finished, and you can see it in real life. The video allows her to then demonstrate it. We're then looking at the viability, so how viable the design really is. Would it be suitable in terms of cost? Would it be picked up? Is it marketable? We're then looking at feasibility of the product. Does it actually do what it needs to do? Can it work? So there's more testing in the feasibility section, as you'll see through the rest of the series. Here we're looking at some SolidWorks testing, and what we're doing is we're measuring where the stress and strain will be on component parts. There's a video of her testing it and showing component parts and how they actually fit. The student then obviously intended to do a final stakeholder interview, but that wasn't possible. So she does some really thorough evaluation herself of all the different component parts. Then importantly, she gets onto modifications. She's identified that there are some problems and issues throughout her testing and feasibility and showing that there are changes that would be needed. So here she does some significant modifications which show what needs to change. Quite often with modifications, they're difficult to spot because students don't give us a before and after. So having a before and after makes, we're not just playing spot the difference, we can actually see what's actually happened. Then some more modifications, so making some simple models to show how things might change. And that's the end of the project. So if that's been useful to you, like and subscribe to the video. Good luck. Detail Technology TV.